Chapter 4, Section 6.1, Part 1 video. In this chapter, we'll be looking at quadratics. We'll be looking at factors and finding the factors and solving for x for quadratics and this, that, and the other. On the first problem, we come to is a traditional word problem for quadratics. It says Delbert stands at the top of a 300-foot cliff and throws his algebra book directly upward with a velocity of 20 feet per second. I know if you had an algebra book right now, you'd probably want to do the same. But take joy in his problem. The height of the book above the ground, t seconds later, is given by the equation negative 16t squared plus 20t plus 300, where h is in feet. So the input time is in input is time and it's in seconds, and the output is height. Okay, so fill in the table for the height equation with increments of 0.5 seconds. So what I'm going to do is I'm going to put this in my calculator, the equation in y1 in the equation editor, and then we're going to do some analysis off of that. The analysis that we're doing will be the same type procedures. It just may be asked in a different way for a word problem or such. Okay, so I want you to kind of understand this equation. This part is called the gravitational constant. It's negative 16t squared. It's really negative 1/2 times g. And g is a gravitational constant of 32 feet per second. So negative 1/2 times 32 will give you negative 16. Okay. The 20t, the linear term, happens to be the initial velocity. And if you remember, it said it was thrown up at 20 feet per second. So that's where that goes in the equation. And then it said we were at the top of a 300-foot cliff. The constant of this quadratic, which is the number without a variable, is the constant, is the height above ground. And that 300 comes from, we're on a 300-foot cliff. So that kind of explains where these numbers are coming from. So what we're going to do is type it in. So it's clear. Really just hit, well, delete. What's wrong with it? Okay, is it clear there? Okay, now. There we go. It just didn't want more work for me. Okay, hit clear here. So negative 16 x squared plus, was it 30? No, 20. 20x plus 300. All right, so we're going to hit graph. My calculator window limits are kind of set up on another problem. So the first thing I do is zoom 6. And so we know it crosses the axis at these 2 points. Now let's do zoom 0 to make it fit. All right, so you get a little bit better picture here. And this point way up here is 300 feet, and he's throwing it off the building. So what I'm going to do is I'm going to my y max. I don't want my y min that much, so about 50 would do. Well, should be a negative 50. And then I'll change my y max to if it's 300 feet above, so I'll go 350. Give just a little bit of headroom up there, and then hit graph. And there you go. It kind of cleans up your graph a little bit and gives a better viewing. Now let's go see what we got to do with this thing. Oh, we got to go find these points. So you can start it at 0, and you can step it by 0.5. And I'm going to auto, and then if I look right here, it has all my stuff there. that I can use to fill in this table. Okay, so we got to worry about that. Now, what is the height? What is the highest altitude Dilbert's book reaches, and when does it reach it? Right? We're not going to use the trace feature to find approximate. We're going to use go back to graph. We use second trace, which is calc. And what we're going to do is we're going to do a maximum because it's opening downward. The quadratic's opening downward. So it produces what I call mountain. And you have a maximum up on the mountain. So we're just going to be left bound and right bound. So I'll just hit enter on that side, then go over to the other side, and then hit enter. Now I'm in between these two, is what I'm trying to tell it to look at to find the highest spot. And when I do that, it is at 306.25 feet, and the time that it reached that was 0.625. So 306.25. So this would be 306.25, and it took 0.625. 625 seconds. When does Dilbert pass him on the way down? Now Dilbert's standing at 300 feet. Okay, so what we're going to do is we're going to go right here and we're going to say, okay, 300 in Y2, and we hit graph. We're going to zoom in right there on that spot for a second. Well, no, we'll just, you can zoom in, and then make it a little bit easier, but we'll just do second trace, and we'll find an intersect, and we'll just make sure it's over here on this side instead of there. The first one. Enter, enter, enter. Alright, so it intersects at 1.25. So we want this 1.25. Because if you think about it, he's at 300 feet right here, and it comes up, so it has to be right there. The other point would be at 0 because he's setting at 300 feet, right? And then how long does it take the book, the Algebra 1 book, to hit the ground? Well, we're going to find that 0 right there. So second trace, and we're going to hit number 2. And we're going to come on down here. And we're going to do a left bound and right bound. Now, if you think about this, as we're progressing through, we need to have it above, and then I need to go below it to create a right bound. So being above it, the X was before the intersection of the X-axis, and below it would be after it. So I'm encasing it. And then it's crossing or hitting it in 5. So that would mean it's 5 seconds. Okay? Because the height at that point is 0. So that's all right there for that first problem. So it kind of threw a word problem in to begin with, and whatnot, but it really gets you used to using some of the things that we're going to be using as we progress forward. So here's this one. Solve by factoring. We're solving for V. And the really cool thing about this is just put we'll put this in Y1, and we can do one of two things. Since it's set equal to 0, then I can find the 0 of it, and I'll show you how to do that. But if it wasn't set equal to 0, we'd have whatever's on the other side equal or put in y2. So here, clear. That's 2. It'd be 2x squared minus 7x plus 6. So 2x squared minus 7x plus 6, I think's what that ought to be. Yep. All right, so we've got it typed in. Hit graph. All right, so we're just needing to know where's it zeroed, right? Where's it hitting 0? Which means where's it hitting the x-axis. So what we're going to do is the easiest thing. Let's just do zoom 6 and see if we can get a better one. Yeah, it's right there. So what we're going to do is that's between 1, 2, 3. So I'm going to take my x-axis and I'm going to say, okay, -1 to 4 and hit graph. You can see where it's right here and then maybe right over there, the 2 places. So we'll go, all right, so second trace, and we hit number 2, which is 0. So we'll be right here. Enter. And then I'll go there, and then enter. So 1.5. is one of the zeros. And then let's do it again. Second trace 2. And what I'll do is I'll move it just a little bit right there, hit enter, and then I'll come over here and force it to look between those 2 points and hit enter. And it's at 2. So you remember how they said factor and quadratic formula and complete the square and all these different things that we could do to solve a quadratic? Really don't need to, because your calculator can do it for you. So these points, 1.5 and 2, that's really where it crosses the x-axis. And what I'm going to do is I'm going to zoom in and kind of show you that. So I'm going to hit zoom 2, and I'm going to, there, right there, hit enter. As you can see, it dips below just right in there, just so just know that that's why we got 2 of them there on that. So let's look at another one. All right, so this one, all right, this is a great example. So we'll go clear, y equals, and we'll hit clear. So we'll do 2x squared, and then 2x, I think is what it, yeah, 2w squared and 2w, okay, all right. So I didn't set it equal to 0. I just said left side and right side. Now when I graph this, it's sitting here. I got to go back and do zoom 6. All right, now here, right in here is where I'm wanting to look. So from -1 to 2, so I'm going to look -1 to 2. We'll hit graph. All right, so I want an intersection here, and there's an intersection right there. Those are going to be my 2 solutions, right? If I were to move everything over to one side, then I'd only be looking at where it crossed the x-axis where it touched the x-axis. So kind of know you can either work this both ways. So second trace 5, and I'm going to back it up. There we go. Enter, enter, enter. And that's at 0. So one of my answers is that x values is at 0. Let's go find what the other one is. Second trace number 5. Now I'm going to find this intersection right up here, and it should be 1, but we're going to look at it. Or it may be 2. It's, I don't know. Alright, so we'll just move it on up there. Alright, so enter, 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 and enter. And it's at 1. So that's my answer, 0, 1. So that gives you a short way to do some things. I'll do some other examples on this, but I'll be using the same principle of doing it with the calculator. So just make sure that you are well aware and can do this. So this is chapter 4, section 6.1, part 1 video.